Okay, so we've got this graph that's below, and first thing I'm going to do is set the equations of the vertical asymptotes, and this is the equation, and finding the vertical asymptotes should just be as easy as setting this equal to 0. I've got x minus 3 and x minus 1, which is going to give me x equals 3 and x equals 1. So we start with that. So part B says find the value, or part B says find the value of B. Okay, so if I look at this, it says find the value B, use the information on the graph. Let's look at this graph. Well, if I want to find B, if I plug in 0, I get the y-intercept of 0, 5. That y-intercept is right here. Okay, so if I plug in 0, what's left is, when I plug in 0, I get 0 cubed minus 0 squared plus 0 plus B over 0 minus 0 plus 3, which is b over 3. b over 3 has to equal 5 because when x is 0, the value for y, or the p of x, is 5. So that means b must equal 15. Next problem says, given that the slant asymptote is x plus 3 and the remainder is a constant, find the remainder when calculating the slant asymptote, determine the value of A, and state the value of the x-intercept. Okay, so we're going to just set all this up. Okay, so up here on the upper right corner, I went ahead and set this up. I know that this divided by this is going to be plus some remainder over here. Okay, in fact, why don't I go ahead and write that as plus some r divided by this whole thing. And it says the remainder has to be a constant, okay? X squared minus 4x plus 3. Now normally when we get a remainder here, it could be an x term as long as it's lower than the x squared term, the degree. But in this case it says that r is a constant, so it must have a constant result here. So I know x goes in here, and I'm going to get x cubed minus 4x squared plus 3x, and I'm going to subtract that off. So the x cubes are going to go away, and I'm going to get negative x squared minus a negative 4x squared, which will be plus 3x squared. It makes sense because that's going to end up being 3. Then negative a minus 3 is going to be negative a minus 3 times x. Okay? Now, I'm going to go ahead and multiply the 3 times x squared. I'm going to get 3x squared. 3 times minus 4x is going to be negative 12x. Okay, and then 3 times 3 is 9, so I'm going to get 9 here. Now, it was given that the remainder is a constant term. So this means that when I subtract this entire thing, and this part may be confusing. Oops, I didn't mean to literally subtract the entire thing. So when I subtract this entire thing, okay, and this is 15 plus 15, I'm going to have 3x squared minus 3x squared. That's going to go away. Then I'm going to have negative a minus 3, so minus a negative 12. So negative a minus 3, okay, plus 12, and this has to equal 0x. Now both of these are x terms, okay? But really what I have is negative a minus 3 plus 12 equals 0. And because that's going to leave us with a if we didn't, we'd have a non-constant remainder. So if this doesn't equal 0, then it doesn't divide out. So solving for a, we get, we subtract 12, we add 3, we subtract 12 and add 3, we get negative a is equal to, I believe that's negative 9. So a is 9. So that means a equals 9. And if a is 9 and b is 15, we are left with x cubed minus x squared plus 9x plus 15 divided by x squared minus 4x plus 3. Okay, now, lastly, it says, what is the value for the x-intercept? What is the value for the x-intercept? From here, you'll need to graph this on your calculator and find the 0. So graph this on your calculator and find the 0, round to the nearest hundredths place. I'm going to leave that to you to solve this value here. Okay, you'll notice it's heading towards the slant asymptote, so it's going to be really close, but not exactly on the slant. So here's the graph on Desmos. I labeled all the important points, and one of the things that you could do is when you graph it, just be attentive to the details, and careful with making smooth curves when you draw your graph. That you're not just connecting the dots of your extrema and your intercepts. You can also see some of how I did this. One of the things I mentioned up here, to apply 2 units per square, I think it's probably better to apply 5 units per square on the y-axis. Sorry, up here, 5 units. I will have told you this in class, but actually, this is probably a nice little problem here, just to be able to recognize and understand all these different features of this graph. So there you go.